You know, it's kind of funny when you think about it. You've got these amazing solar panels on your roof, soaking up all this free, clean energy from the sun. But what happens if you're not home during the day to use it? Where does it all go? Well, for most people, it just gets dumped right back to the grid, and you get paid pennies for it. Today, we're going to look at a brilliant DIY project that takes that problem and just solves it.
So let's put a number on this. Get this. For a typical home with solar, a whopping 70% of the power you generate can end up being sent right back to the grid. And it makes sense, right? Your panels are churning out the most power right in the middle of the day, exactly when the house is empty and you're not using much electricity. It's a huge waste of potential.
And this is the exact question that got business analyst and home automation geek Paul Kosteline thinking. He looked at his own setup and said, okay, how can I actually use more of my own power, without having to spend a fortune on some crazy, unprofitable new gadget? His journey to answer that question is what this is all about.
Now, to really get why this project is so important, we have to talk about a massive shift that's happening in the energy world. In places like the Netherlands, the rules for solar owners are about to get a major overhaul. And suddenly, that 70% of unused power isn't just a missed opportunity. It's going to start costing you real money.
Okay, so this slide really breaks down the financial hit that's coming. Right now, a system called net metering basically lets you use the grid as a free battery. The power you send out cancels out the power you pull in later. But after 2027, that's going away. You'll get paid way less for the energy you sell back than what you have to pay to buy it. So the bottom line is, using your own solar power the moment it's generated becomes absolutely critical for your wallet.
So, you need a battery to store all of that extra midday solar energy. What do you do? I mean, the first thing you probably think of is one of those big, expensive home battery packs. But Paul had a different idea. He realized he had a much, much bigger battery already sitting in his driveway every single day.
And here's the choice he was looking at. On one hand, you've got the dedicated home battery. Super expensive, limited in size, and honestly, who knows if you'll ever make your money back. But on the other hand, your electric car. It's got this massive battery. We're talking 60 kilowatt hours or more that's literally just parked there doing nothing. The real genius here wasn't buying a new battery. It was figuring out how to use the one he already owned.
So just how big of a difference can this make? Well, without any smarts, your home might only use about 30% of its own solar power. But by intelligently charging your car only when the sun is out, the goal is to crank that number way up to 50, maybe even 70%. You're more than doubling how much of your own free energy you use just by being clever about timing. All right, now for the really cool part. Instead of dropping a couple $1,000s on some off-the-shelf smart charger with a closed system, Paul went the DIY open source route. So let's break down exactly what he used to build his own custom solution.
The whole philosophy here was about being smart and affordable. He started with a recycled charger case, then added a simple, standard EVSE controller for about €100 and a little ESP32 smart relay board for less than 50. But the real secret sauce, that's the open source software that brings it all to life. I mean, we're talking a tiny fraction of what a big commercial unit would cost.
So, how do these simple, inexpensive parts come together to create something so smart? Well, Paul came up with this really elegant 3-layer system. The best way to think about it is like a human body. You've got the muscle, the nervous system, and of course the brain. Each one has a very distinct job.
First up, you've got the muscle. That's the Simple EVSE board. Think of this as the brawn of the operation. It's the tough, high-voltage part that does the actual work of safely pushing power into the car. But here's the thing. It's not smart. It's just waiting for a command telling it how hard to push.
Okay, next is the nervous system, and that's the ESP32 controller. This little chip is the essential go-between. It gets simple instructions over Wi-Fi, something like, hey, charge at 10 amps, and it translates that into the very specific low-level electrical language that the muscle can actually understand. It's the universal translator between the digital world and the high-power electrical world. And finally, we have the brain. This is an amazing piece of open-source software called EVcc. It runs quietly on a small server inside the house, and it sees everything. It knows exactly how much power the solar panels are making, it knows how much the house is using, and it makes all the strategic calls. It says, aha, we've got 4 kilowatts of extra solar power right now. Tell the car to start charging, now.
And this is what it all looks like from your point of view. The software gives you this beautiful, simple interface where you can see it all happen in real time. You see the sun powering your home, and then you see any extra power flowing perfectly into your car. The whole idea is to charge with sunshine and make it completely automatic.
So how does the brain actually talk to the nervous system? It's way simpler than you might think. The EVC software just posts a little message to what's basically a digital mailbox, with a specific address. The ESP32 is constantly checking that one mailbox. The moment a new number appears, it grabs it and tells the muscle what to do. It's just this beautiful, seamless flow of data.
Now, putting all this custom code together and digging into complicated technical manuals sounds, well, hard. But Paul had a secret weapon, a modern tool that made the whole process way, way faster, an AI programming partner. And it's really important to understand how he used it. The AI wasn't some magic button that wrote the whole thing. No, it was more like a research assistant on steroids. Paul would ask it to explain a complex charging standard or give him some basic code to start with. The AI would provide the raw ingredients, but Paul was still the chef. He had to adapt it, integrate it, test it, and perfect the final recipe. It's a human-led process, just accelerated by AI.
So, you might be wondering, after all that effort, why bother? Why not just buy something off the shelf? Well, the reasons for going the DIY open source route are huge, and it's about way more than just saving a few bucks.
It really boils down to three massive wins. First, the cost. It's just a tiny fraction of a commercial system. But I think more importantly, you get total flexibility. You're not locked into someone else's idea of smart. You can change the code, add features, connect it to anything else in your smart home. And maybe the most critical point, you are in complete control. There's no reliance on a company's cloud server that could shut down one day, there are no monthly subscription fees, and all your private energy data stays in your house, where it belongs.
You see, a project like this does more than just save you money. It completely changes your relationship with energy. You stop being just a passive consumer and you become an active manager. By weaving together solar panels, an electric car, and some smart open software, your home becomes its own living, breathing energy ecosystem. So the only question left to ask is, are you ready to pick up the baton and be its conductor?